There we go. Great. Yeah. So this talk is going to be kind of unusual for RacketCon because I'm not going to tell you about how to use Racket to build an amazing new programming language that lets you do more and more and more. I'm going to tell you how to use Racket to build a programming language that lets you do less. So I guess I should start by suggesting why on earth this is something you might want to do. So maybe you've been in a situation like I was a couple years ago. I got curious about the crazy stuff people are doing with web programming these days, and I went to download Node.js and all this associated tooling. And so I went to look at how to install this and found this web page that told me there's a pretty robust shell script at this URL. Just download it, pipe it into shell, and you're good to go. And as a sort of security-minded person, this made me a little nervous. But I got to thinking about it, right? And so what's my alternative, really? So, okay, instead of just running this script, I'm going to download it and stare at it for a while. And you probably can't see this, but if you've looked at any shell script, particularly a pretty robust one, you'll imagine that looking at the code doesn't really help, right? I have absolutely no idea what this script is going to do, and I'm actually giving it a lot of control over my computer when I run it. So maybe you're kind of nervous still, so you go on Stack Overflow and you say, I downloaded this shell script from some website. It's really big. It's got weird characters in it. Can anybody tell me how to figure out if it's safe to run? Or give me a way to limit its rights in the system? And unfortunately, like for this person, you won't get any answers. But this person is sort of onto something, right? Because there's this really old security principle that was articulated in the 70s called the principle of least privilege. And it says that every program that you run should really operate with the least amount of privilege necessary to get its job done. And the sort of intuition here is that if this program or script is malicious or just buggy, right, if I haven't given it many rights to my system, the sort of worst possible case of what could go wrong isn't going to be that bad. And so the idea behind Shill is to see how we can apply this idea of least privilege to scripting. So the core idea in Shill is that when you write a Shill script and you go to look at it next week, or you've downloaded one off the internet, instead of having to figure out what that script does, it should come with a contract that tells you something about what it might do when you run it. And that contract is going to serve as a simple security policy that will let you look at it and say, yeah, I'm OK with the things it's going to do, and run it, and recognize that it's safe. Of course, you're a Racketeer, right? So you don't want just to be able to run little scripts that have a policy on it. You want to be able to build larger programs and more complicated things by composing different pieces of software. So we want a mechanism where my shell script can call into some other shell script that someone's provided, right? And I should still get some guarantees about what's going on. Right? And at the same time, I want to write a shell script that actually has to do real work, right? And so there's probably going to come some time when I need to run some code that isn't written in Shill, right? An executable that installs, or maybe something I just compiled. And so within Shill, we're going to provide a mechanism to take that contract that you wrote for the script and apply it to whatever executables you need to launch. And we do this with a sort of separate mechanism that builds a really customized sandbox for your executables based on what's going on in the Shill script. And so the sort of big picture idea, right, is that you should be able to download a Shill script, look at its contract, understand whether or not you think it's safe to run, and then get a start-to-finish security guarantee that everything that script does, whether it's things written in the language or executables it calls out to, should satisfy that security policy. So this is the big picture. Let me actually dive in and show you sort of how Shill works and achieves this goal. So at its core, the security idea behind Shill is something called capability-based security. And so the idea in capability-based security is the idea of a capability, which is an unforgeable token of authority. The best metaphor I've ever heard of this is like a car key, right? So my car key you can think of as a token of authority. That means if I get in the car, I can drive away with it, right? Because by having that physical object, I'm sort of granted permissions to do something. And this sort of has nice security properties because it means that I can really flexibly control who can drive my car, right, by who I give my car key to or who I give copies of my car key to. And so in the same way, Shill is only going to be able to access resources on your system through special values within the program that act like that car key. And without them, you can't do operations like write to files or speak to the network. So let me give you an example, right? So suppose that I had some example capability around here. This is for a directory on my system. I can use this to do operations on my system. So for example, I can list the contents of a directory. But it also gives me access to do more interesting things in the system. So I can derive a new capability by, say, looking up an entry in this directory. And that will return to me sort of more rights to access other resources on my system. So now I can write to this file that I just got a capability for and say, hello, RacketCon. Unfortunately, my REPL's kind of slow for reasons I don't know. And of course, I can read from it. And so the key idea here is sort of like, unlike other scripting languages that you might be used to, I can't just like write some random string that lets me write to some file in a directory. I actually have to get one of these capabilities from somewhere. And as we'll see as I go on, the sort of power of Shill comes from the mechanisms we give you to control where these capabilities come from and where they go. So a script in Shill looks a lot like a script you might write in another scripting language, maybe like Python or something with ugly syntax like this. Right? So like this is a function I've written that copies files from one directory to another, right? So it takes two directories as input, a from directory and a to directory. And for each entry in the contents of the from directory, I'm going to like look up that file, create a new file in the destination directory, and copy the contents from one to the other, right? Pretty straightforward, as you might expect, right? So I can require this script, and then if I have, say, a directory full of files that I want to transfer to some other directory, I can just invoke my script that's nice and reusable in other programs that I write to do the copy between one and the other. And just to prove I'm not cheating, right? Lo and behold, I copied a bunch of files. So this, on its surface, doesn't really seem to really address security in any interesting way. But the key thing is that the way we've structured this language means that this script, this copy function, has no capabilities by default. So there's nothing I can write in the body of this function that will just say, like, take a string for, my password file and return a capability that would let me read from it. And that means when I invoke a Shill script, I can think about what it's going to do just in terms of what capabilities I pass in as arguments, right? So if I say copy files from this one directory to this other directory, I know just very easily that there's absolutely no way it's going to modify some files that are in some completely unrelated directory or write them out to the network, because it just doesn't have the capabilities it would need to do that. And that's sort of where the core of Shill's security comes from. On top of that, though, we actually use contracts, like you might be familiar with in Racket, to give you even more fine-grained control over what a script can do. So here I've taken the copy function that I just showed you before, and I've added this contract to it, which describes how it's going to use the capabilities that I give it. So it says the from argument to copy, I'm expecting a directory. And the things that I'm going to do with that directory is I'm going to list the contents of it, and I'm going to look up files from inside of it, and the thing I'll do to those files is I'll read from them. But I'm not going to write from them or do anything like that. And for the to directory, I'm expecting a directory, and I don't even want to be able to list the contents of the directory. All I need to be able to do is create new files, and I'm going to write some content to them. And at a kind of first pass, this works just like you're used to contracts in Racket working. So suppose that someone else wrote this copy function, and I was incorporating it into something I needed to get done. But for whatever reason, I decided that I was going to pass in a file instead of a directory. Well, of course, this is going to go wrong, but instead of just sort of silently going wrong, like with contracts, I'm going to get an error message that told me what went wrong and stopped stopped execution so things wouldn't go worse. So right, this says contract violation, I expected a directory, but you gave me a file in the from argument. Just sort of nice from a programming perspective, but again, haven't really addressed security. So let's maybe consider a different way that I might invoke this copy with 2 directories, and we'll see what happens. Oh, and I got another contract violation. So that's kind of unexpected, right? It worked before. So what does this say? It says copy broke its own contract. It tried to append, but it had insufficient privileges for append on something that it looked up from the from arguments. That seems a little weird. So if you actually go and look in this code, it turns out that sneakily, I added this malicious line, right, which as I'm copying files from the source to the destination actually goes and writes this evil message into the source directory that it wasn't supposed to. And so nicely, what the language has done for me using contracts is it has actually enforced this sort of very high-level specification of what I expect a copy to do, right? Move things from one directory to another without changing them in the original one, and turned it into this sort of executable form that gives me some security properties. And the sort of thing that makes all of this works is the fact that, like I said before, these scripts don't have any capabilities by default, right? Which means all of the capabilities they get, they must actually receive as arguments from somewhere else in your program or from the REPL where you actually create them in the first place. And so that means that this contract actually tells me everything I need to know about the security of this function, right? Because those are the only capabilities it gets. That's all that it can do with them. And then I mentioned before that we have this sandboxing mechanism that lets you actually call out into executables. So I'm not going to go into great detail about how that works, but the key notion is that there's this exec operation that you can do on a file, which invokes it with a bunch of arguments, and you can pass in capabilities for things like standard out, standard error, and other sets of capabilities that this executable might need to run. And what this basically enables you is it gives you a programmable sandbox, right? So I can write a program that, when given some set of inputs and says needs to run cat or clang or whatever executable, can reason about what I'm trying to do and come up with a set of capabilities that should enable it to do that, but not other things that I want. And you might notice here that, like, okay, this script, which I didn't really describe, but all it does is call cat on some file. But it has this huge contract because it needs all of these different resources. And that's because it turns out that on a sort of standard operating system installation, you have all these shared libraries and things. So doing just about anything on your system ends up needing all of these libraries and all of these configuration files that tell the libraries how to work and all of this stuff. But because this is embedded in a programming language, right, you don't have to write this. We actually, like in our standard library, can create abstractions or functions that you might pass instead of all these detailed things, a directory or a capability to your path environment, and then a string describing what your path should look like, and it will take care of like collecting the necessary requirements for you. And so you get a lot of leverage out of this sort of programmable nature that being embedded in a programming language gives you. So that was sort of a whirlwind tour of Shill and what it's like to program in Shill. I want to tell you a bit about how it works under the hood and how Racket actually sort of made it really easy to get going on this project. So there's 2 main components. The first, which I'm not really going to talk about, is that black box capability-based sandboxing layer that we actually built as a kernel module for FreeBSD, and some new system calls and things we had to add. But sort of the bigger chunk I want to talk about now is hashlang Shill in Racket, right? Which was remarkably easy to build. So we started with just a capability-safe subset of Racket base. We went through and said, okay, don't give them open a file, right? Don't give them some mutable data structures that'll let them squirrel away capabilities, that kind of thing. And then on top of that, we used sort of macros and like a set bang transformer to set up the types of mutation that we wanted to allow in the language. And then on top of that, layered a require transformer that actually goes and checks when you require some code from Shill, it checks, is this Shill code? And if you try to require something that isn't Shill, it errors out. And so that means you can't subvert Shill by just requiring some Racket FFI library or something like that. And then we use the FFI unsafe, which lets you amazingly quickly write connections to libraries that implement the sort of low-level details. And then finally built the security contracts, right, are a fairly straightforward adaptation of combinators that already exist in the Racket contract library. So sort of all the great tools that Racket makes available really let us kind of hone in on exactly what we wanted to try and do really quickly. So as Alexis was talking about earlier, definitely Racket is an amazing environment to play around with language design. And then, of course, we have a custom reader so that we could hide all the intimidating parentheses from scripting people. I think I'm going to put more parentheses back in, though, because I like them. Whoa, what's going on? So what's next? As Matthew mentioned, we're working on a commercial version of Shill, which has some sort of exciting sub-projects. So we're working on porting that FreeBSD infrastructure over to Linux so that it's more accessible to people, and also so that I can write more of Shill within Racket itself, which is going to let us do exciting things like let you write filters and stuff in your contract combinators that get applied to executables themselves that are written in Racket. And we're working on a plugin framework that would allow us to add more and more different types of capabilities to Shill for things like process management, job control, databases, and you name it. So if you're interested in learning more about Shill, either just come talk to me, or we have a website at shillang.org, and you can actually download this virtual machine in case you don't happen to use FreeBSD already, and play with Shill. So I'm happy to answer any questions. Thanks.
Hey, first question.
Hello. So I noticed that all your files were in Shill/Cape or Shill/Capability.
Yeah.
I know in the past you had a ambient language. Has that now disappeared?
We still do, but it's sort of been subsumed by the fact that I implemented a REPL. And the REPL basically gives you access to the same capability creation primitives. So the idea is your Shill scripts don't have any capabilities themselves, but whatever you use to launch them does. So we have to have this separate language where you could create capabilities and then call Shill. Now we just have a REPL.
Okay.
Yeah.
Okay. Could you show me the definition of plus read? Of plus read, yeah. It sounds safe, and I trust you. But like with a car key, I could take my Toyota key, scratch out the logo, and put BMW on it.
Yeah, so there's a certain level of trust in knowing what the capabilities mean. And that gets even more complicated because since they're first-class values, you can define something like readable or writable. But you're still sort of better off. You need to know what the standard library capabilities and stuff mean. But you don't have to go and understand a pile of awful bash code.
Okay, well, we've got the question row here.
So do you think the typical case would be the producer of some script would be providing that capability block, and you would read it and feel comfortable that it's doing what you expect it to? Is that the use case?
So I suspect that use case will be fairly uncommon. That there's sort of two modes of use that I see. One is I have some executable I want to run. Because we have this like programmable sandbox, it's more straightforward than in some other tools to actually wrap that unsafe thing in your own custom created thing. Because you don't have to figure out everything it should just do. You just need to know what does it need to be able to do for this invocation I want. And then the other programming model is if I have some task that I actually care about a lot, I can program directly in Shill. So when I was a TF, I actually implemented like grading scripts in Shill directly. And then I could enforce really sort of fine-grained policies about like, you know, when I'm compiling this student's code or testing the student's code, it can't mess with other students' code. I can get sort of as detailed as I want by programming directly in the language.
So your motivating example with Node, would you wrap that entire shell script in this?
Yeah, so the easy way to get started if the Node guys don't want to start programming in Shill, right, is, well, they should have their working directory where I'm doing the compiling, and then they should have the install directory or something. But I can say, don't change stuff that I don't want you to, just put new stuff.
Okay, all right, I'll give Jay the last question here.
I feel like this is very similar to the Android security policies. that you can see on the Android, the Google Store or whatever. I mean, I have Stockholm Syndrome, so I don't actually know what the Android environment is like, but I get the impression that a lot of people just sort of say, yeah, whatever.
I think there is that to a degree, but I think a lot of that comes from the fact that the permissions are so coarse-grained, right? That like my option for something in Android is going to be like file system. And like, okay, I guess, right? Whereas with us, we can give you the policy that's like, you know, this directory or the directory you pass in as an argument, which is sort of maybe much easier to get your hands around than these sort of broad questions.
All right, thanks, Scott. I'm sure Scott has available for more.